All right, welcome. Today we're going to talk about net change as the integral of the rate of change. So, this is one way calculus is used a lot in both physics, economics, finance, math, chemistry, things like that. And it's really just a statement of the fundamental theorem of calculus. Remember, the fundamental theorem of calculus said that if you integrated from a to b, f prime of t dt, well, to do the integral you needed an antiderivative, so an antiderivative of f prime is f, and then you evaluated it from b to a. So that's the fundamental theorem. But the point is, this term here is just the rate of change of f. And this term is just the net change, or total change of f. And so you can calculate the total change of f by integrating the rate of change. And a lot of times what we're given in the world is the rate of change. So here's a typical example. Say water is pouring onto the floor at a rate of 2 plus 5t liters per hour. Here t equals to 0 is corresponding to 7 a.m. And the question is, how much water is dumped on the floor between 7 a.m. and 9 a.m. All right. Okay, well, the point is this. You should label something. Let's let W of T be the amount of water, the number of liters of water on the floor at time t. And we're going to set this up again so that time equals to 0 is corresponding to 7 a.m. So that's the total number of liters of water that have been spilt on the floor. The total amount of water on the floor. And so the question is asking for what is, how much water is there at 9, so that would be at time 2, minus how much water there is at time 7 a.m., which corresponds to time 0. So this is the amount of water amount of water dumped on the floor between 7 and 9. All right, because this is how much water, this term here is how much water there is at 9 o'clock, and then subtract off how much water there was at 7 o'clock, and the difference will be how much water was dumped on the floor between 7 and 9 o'clock. All right, so that's what the problem is asking. What is that? Okay, well, this is a rate of change problem. This number here is the same as integrating from 0 to w prime at t dt. But this is the rate of change of the water. It's how much water is being dumped on the floor at every instant. And the water, as we looked back up here, was dumping at a floor at a rate of 2 plus 5t liters per hour. So you integrate the rate, 2 plus 5t, and you get 2t plus 5/2 t squared, evaluated from 0 to 2. Plugging in 0 doesn't do anything. Plugging in 2 will give me a 4, and then 4 over 2 is 2 times 5 is a 10. So we end up with 14 liters on the floor. All right, that's our first example for getting net change by integrating the rate of change. Ciao.